Welcome again to my channel, Electronic Made Easy. This is Manny. What I'm discussing now is how to simulate your project using the simulation software, Proteus simulation software. So now, for demonstration, I would like to draw this circuit here to my simulation before actual connecting to my actual project. So what is the purpose? Instead of wasting time connecting and building the program and so on that does not work, first you have to work in simulation. It's easy for us. So once it works in simulation, then we have a 90% chance that it will work in actual. Since most of our project in Arduino will be using the display for the actual display of any of our parameters, right? For example, we have connected here and a sensor, then we can read the sensor through our Arduino Uno and then display it in our display LCD display. So I choose this project in order to simulate this here in my Arduino Proteus simulation software. So I will like to show you before connection to discuss some details of our LCD to understand how to use this one. So we are using now 2 by 16 LCD. 2 by 16 means two lines here, two lines, and 16 character. That means in this LCD we are only limited to two lines, and each line have 16 character display. So more than 16 character, we cannot display more than 16 characters in one lines. Okay, so in our 16 by 2 LCD we have 16 pins. Now this is parallel LCD. We are talking about parallel LCD. So we have ground, VCC 5 volts. This automatically will be connected to our 5 and ground of our Arduino power supply. Then VO, we can use here VO as your contrast. Contrast means you have to adjust the brightness of your LCD through adjusting the voltage here. So we know already that we can implement that using the potentiometer. So the variable voltage of your potentiometer will be at the center. It will be connected to your VO. And of course, the extreme or one and third terminal will be connected to our 5 and ground voltage. So if we adjust the knob of our potentiometer, it will adjust this voltage. So hence it will adjust the contrast voltage of our LCD. We have also the register select, the RW or read write pins, enable pins, and the data line pins. So later I will discuss what is the use of this one, anode and cathode. Anode and cathode is simply the backlight of our LCD. So this is optional to our project. If you want the brightness or the backlight, there is a backlight of your LCD, we can use this anode and cathode. We can just connect the cathode in the ground, and then we can connect the anode to the 5 volts power supply of our Arduino via resistance. So we will make a series resistance. So less than 1K or 1K like that, to prevent or to protect our LCD from damage. Okay, so here we'll go back to our Proto simulation software. By the way, my Proto simulation software is like this one. I installed this in my PC. So I open this and I open my circuit diagram here. Now, if you want to select or make components in Proto simulation software, you can just click here, this icon, or this click here. So first, if you are new, opening new of your Proteus like this, run this. Okay, then click this schematic capture and you will be brought in this window, the working space window. So to take the component, you can click this window or icon, the component mode, or P here. So I click here, there is Arduino already. But here, notice if you are newly installed or your Proteus is newly installed, you cannot find this Arduino here. You have to install this manually in your Proteus. So how I will demonstrate for a while what you are going to do. go to Google, and then here search Arduino library for Proteus. Click here and open this site. So as you can see here, there are too much library, not only Arduino. So you can just navigate this site. See here. See, if you are using in the future a GPS device, you can simulate it using the GPS library. There is also XB library, ultrasonic library, PIR library. You can just navigate the site and you can find many libraries. Since our concern is only Arduino library for this time, we can, here there is Arduino library, then download this one. And here you can find this link, and there's a count here. Okay, so 20 seconds foremost to wait. Okay, 8, 7, 5, 3, 1, 0. Okay, so download your files here. So here, after downloading the files, you can just browse these files there in your folder, downloaded folder here. Actually, I already downloaded these files before, but to show for demonstration to you, first, not to confuse for the extraction of this, you have to copy these files to a certain folder here. Copy, make a folder like library, Arduino. Proteus, like that. Proteus. Am I correct? Okay, Arduino here. Any file name you want. Okay, open this and copy that files here. So once you copy that one in one folder, you have to extract that, like right click that one and extract here. So after extracting, notice that you have two files here, TEP files and library files. Okay, what you do, you have to copy these files here, right click, copy, and then go here, go to C, again C, click this one, and go to program data directory. So in program data, you can find these folders. You open the Lab Center Electronics, and then there you can find the folder of your Proteus simulation software. Open, and then go to library, and whatever you copy there, you have to paste it here. Since I already installed my Arduino before, so no need to paste that again. So what you're going to do, if you are new, just right click here and then paste. Okay, after that, close, and you can open your Proteus and you can find Arduino here. Okay, so since we are using Arduino Uno, so we have to select Arduino Uno here, then okay, then put it here. Okay, since in your circuit diagram we are also using the LCD, so you can again click here and then you can search here actually LCD. Okay, the LCD that we are using is 16:2 here, like this. So this one. Okay, put it here. By the way, LCD also is, you cannot find this in your Proteus simulation software, so you have to again download as we did, same as we did with Arduino. So here, if you can rearrange the two components. So now we will connect our diagram here in simulation software. So here, if I will review, okay, here if I will review the LCD, we said that this ground, VCC, and RW will be connected to our ground and power supply. But here in simulation software, we cannot find it 5 volts here and ground. Not like in our actual Arduino, which is like this in our drawing here. If I expand this one, here we have 5 volts and ground, but here in our simulation software we cannot find it. So what is the remedy? Okay, what is the remedy of that? Actually, there is a built-in power supply here. We will just right click in this Windows, place, go to terminal, and then power supply here. Okay, so also we need ground, so we have to right click, terminal, and then go to ground and ground here. So the standard connection of our LCD, first, before connecting the data lines, we have to connect the necessary power supply of our LCD. Okay, so here, if you noticed here, sorry, here we have BSS, BDD, BEE, RS, RW. So the standard connection is that this BDD is our power supply of LCD. This is the contrast, VO in our LCD here. So contrast, you simply connect it to the power supply here, and the BDD also to power supply here. BSS also will be connected to our ground here, and the RW, this one, read write pins. Okay, so based on that connection, we'll follow this connection here. So our power supply will be connected to our BDD, and this VE, our contrast for simulation, will connect this here to be supply. But here in actual connection, we will connect it with this one. So our VSS, as I said before, we'll connect this to our ground here, and our RW, the read write. Since we are only have to display in our LCD, we don't want to read the values or the data in LCD. Since if you look at the manual of this, the RW or read write pins is active low, so we have to connect it directly to the ground here. Sorry, from here to ground. Okay, that is the connection for power supply. Okay, for our data here, RS, register, select, and enable, and the data, we will connect this to our Arduino since this will be programmable. So based in our diagram here, we can see for expound here, our RS here, this is our RS, will be connected to the 12 pins of our Arduino, the digital pins. Our enable here will be connected to the 11 here. Okay, so the rest of this connection we have already connected here. So where is our RS? This one. Where is our pin, digital pin 12 here? We will connect this here to our RS or register select. Okay, digital pins of our Arduino will be connected to our enable here. So enable pins will be connected to 11 and RS will be connected to 12. This is our data lines. Now, most of our application of Arduino LCD, we are not using the whole data lines, 8-bit data lines. So we are just using the most significant bit because we are programming our LCD by 4-bit programming. 4-bit means we are only using the most significant bit, which is the D4 to D7. So based on this connection, we are connecting the D4 to our pin 5 of Arduino. So where is our pin 5 of Arduino? Here. We'll connect it to D4 here. Okay, then and so on, we'll connect the D4 digital pin of our Arduino 4 to our D5 of our LCD, and so on. D3 will be connected to the D6. Okay, D2 will be connected to our D7. Notice here we cannot find the anode and cathode because this is just simulation. Okay, so that is not found here in simulation, only in actual. So after connecting this circuit, now we can load the program actually by virtual programming here in our simulation. So how to do it? We can proceed to our simulation here by loading the program in our simulation software by opening the Arduino IDE here. Okay, so actually it pop up this program, but this is the program that we are using. This is a sample program of our Arduino IDE. How we can obtain this program? We can just click here in our Arduino IDE, go to example, then we look for liquid crystal example and hello world library example. Okay, so if you open that one, this is the program. So we can use this program to test our LCD in our simulation. So as usual, as in my previous video, we are discussing the library. Okay, library is used to simplify the programming. So each device on our Arduino application, you can find the library. So in this case, the liquid crystal library is used. So here, notice in programming, so this is what I'm saying to you, that here in constant you can define the pins here. So if we will go back to our diagram here, so here we are connecting to pin 5432 for our data lines D4 to D7. Actually, we can change these pin connection by changing the constant here. For example, this 5 means data lines or digital pins 5 of Arduino, and D4 is connected to that one. So if you decide the D4 here to be connected in other pins like 6 here, so you can just replace here 6. Okay, or any pins, if you change here you can do it, but here we are deciding to follow the actual diagram that we are using, this one, which is this one. Okay, so here the program simply what the program will do will just simply display in the first line the hello world character. Okay, so how to apply this in your simulation software? So simply go here. If you navigate here, there is a check here. If you are using the Arduino before, this check here is to compile your program. So meaning you have to check your program whether there is an error or your program has an error or not. So here, this is if you upload your program to the actual hardware of your Arduino. So since we are just simulating, we will make sure that if you click this one, your Arduino is connected to your PC. But since you are only simulating this program to our simulation for software, all you need to do is click this one. Before clicking compilation, click here, File, Preferences, click here, you pop up these windows. So if this box here is not checked like that, you have to make a check like that and then okay. Okay, so then compile your program like that. Wait for the confirmation that the program is correct. So if it is done compiling, you can expand this and search for this directory here, the hex directory. This is the hex file during compilation. So you have to copy this directory here, Control C, go to your Proteus simulation, double click the Arduino here, and then copy it here, Control V, then make OK. Now we are ready to simulate our circuit using the simulation software. We draw it and then we load the program, the hex file of the program, to our Arduino. What we're going to do is just to run our program. Let's check. See, our Arduino is displaying, or our LCD is displaying a hello world character. So for example, if you play with the program, you have to change this character here by other character. Simply stop the simulation software, go to your program. So simply change this character, for example, okay, electronic guy, my favorite word, guy. So as I said, you are limited to 16 character here. More than 16 character, it cannot be displayed. Okay, it will cut until to 16 characters. So if you run again the program by compiling, okay. So if you already copied the hex file before, no need to copy it again. It will just be updated automatically since the hex file is already saved in your temporary files in your PC. So just compile and then run again here. See, the character changed to electronic guy. This discussion of electronic simulation using the Proteus. You can use this in your future project. I hope this discussion will help you throughout your way, and I hope you understand what is the idea of simulation or simulating your software before connecting it. So I hope, and I good luck to your future project. And this is Money, Electronic Made AC channel. Please subscribe if you want more videos to be seen here. Thank you.